Okay, today we're going to talk about how we can use the line of best fit to do something that we call interpolation or extrapolate. There shouldn't be a D on that. Okay, so how do we use the line of best fit to interpolate and extrapolate? Now again, this is an 8th grade statistic. Use the equation of a linear model to solve problems in the context of bivariate measurement data, interpreting the slope and the Y-intercept. Okay. Below is a sample of data taken from 6 people. It records their arm span and their height in centimeters. Okay, is there a correlation between the two measurements? That's a question that someone might ask. So I have 6 measurements of arm span versus 6 measurements of height. And so what I'm going to do is make a scatter plot, and I've made it in the following table. So I've put arm span on the x-axis in centimeters, and I've put height on the y-axis in centimeters as well. Okay, now it doesn't necessarily mean that height depends on arm span or arm span depends on height. In fact, it is not the case that your height causes, the taller you are, it causes your arm span to grow. Okay, there's another factor, a third factor here, which is how much growth, human growth hormone you naturally have in your body. So how much you grow is a genetic component of it's just a genetic component, right? So it doesn't, these two things, there may be a correlation, but there's not a causation. Okay, so what I'm looking at is I'm trying to figure out, and by the way, this graph isn't entirely right because it actually should have this squiggly line here and here, because the space between here and here is 160, right? But then the space between the next two is 5 centimeters. Then, so after it jumps up to 160, it goes up by 5 centimeters. And same here. After it jumps up to 165, it goes up by 10 centimeters each. Okay, so it actually should have those little squiggly lines. Those are called breaks. Okay, so I calculated the mean arm span to be 169.6 centimeters and the mean height to be 171.5. So I want to find the line of best fit. Now I'm going to graph these. So I'm going to graph the point 169.6, 171.5. Okay, so 169.6 and 171.5 would be somewhere around here. Okay, so I know, let me plot that in red here. So I know the line is going to go through that point. Now, conveniently, I also know that there's a point 0, 0. That's because if you have an arm span of 0, then you must have a height of 0. Like, no one would have an arm, unless you had no arms, in which case you're someone who we wouldn't take data from because depending on the reason why you don't have arms, it doesn't necessarily mean that, you also do not have a height. So we're going to assume that when the arm span is 0, the height 0. So this goes through the origin. So when it goes to the origin, you naturally have another point by which to build the line. So here's the line, and I may not have drawn it very straight. And this is sort of a moderate positive correlation. You can see the line. And we don't have that many points. We have only 6 points. Maybe if we had more than 6 points, it would be easier for us to tell. The fit of this line. So it's not super close, this line from the points. So this would be a moderate positive correlation as opposed to the ones we've seen in the past, which are sort of more strongly positively correlated. Okay, so we have these 2 points here. Let's make the equation of the line. So I wrote the points on another piece of paper here, and let's put them in a coordinate pair. And it's very easy because if I'm subtracting the coordinate 0, 0, I would just get 171.5 and 169.6. So I can just go ahead and take 171.5 divided by 169.6, and I would get, remember, round to the nearest hundredth here. So I would get 1.01. Okay, so that's my slope, that's my M. Now, in order to find my B, I want to put this information in. So I have 171.5 is equal to 1.01, the slope times the... Oh, actually, what am I talking about? My y-intercept is going to be 0, right? Because it goes to the point 0, 0. So that's my x-intercept, and it's also my y-intercept. This is a graph of direct variation. So my equation is just the slope of my line times x. So y is equal to 1.1x. Now let's interpret this slope. Oh, I have a couple questions to follow up on this. I should go back and put this on my line. Y is equal to 1.01x. Now this is a causal relationship. Now I talked about this before. It's not a causal relationship. They are moderately positively correlated, but one does not cause the other. Height does not cause your arms, the taller you grow does not cause your arms to grow taller. There's a third factor in this whole situation, which is your genetic disposition to grow bigger or be smaller, okay? And the bigger you are, the bigger every part of your body is, including your height and your arm span. What does the slope, so no, there's not a causal relationship. Remember, correlation does not imply that there's a causation. What does the slope of the line mean? Well, the slope was 1.01. So remember, that's the change in y over the change in x. So our y here was our, let's just check back, was our height. So that was our height versus 1 centimeter of change in our arm span. So that means for every 1 centimeter growth in arm span, it's a 1.1 centimeter growth in height. There's a 1.01 centimeter growth in height. And by the way, just looking back on our graph for a minute, it looks as if the points were not very close to the line, but remember, this line is really zoomed in, right? Yes, it starts at the origin, but we make these breaks in the graph, so it's really, really zoomed in. If I were to just have drawn this regularly from 0 to 180, going up with no breaks, it would appear that this line would be very close to the points, because it would not be as zoomed in as it is right here. And I should have made a height versus arm span should be the name of the graph, okay, both in centimeters. So this, it kind of looks like the points aren't closely fit, but that's also because we're really zoomed in, okay? So what does the y-intercept of the line mean? The y-intercept was 0, remember. So when arm span is 0 centimeters, then height is 0 centimeters. Okay, that's what that means. Now, use the equation of your line. So we're going to do some predicting, okay? So if we use the equation, so there's two types of predicting. There's interpolation and extrapolation. Interpolation is trying to use the line of best fit. So interpolation is in using the line to predict something within the range of the data set. So I want to use the equation of your line to predict the arm span of a person who is 1.61 centimeters tall. Okay, so if I do that, if I look back on my data points, 1.67 is within the arm span that I was given, right? The lowest I was given was 159, the highest I was given was 179, and 167 is certainly within that data point, within those data range. That's interpolation. Inter meaning it's part of the data. Okay, extrapolation is going to be outside of the data that you're given. So let's use this. So our equation is this. Okay, remember x is the arm span, and wait, let me make sure. X is the arm span, and the height is y. So I want to put the y in for 167, and that's 1.10x. Now to solve for x, I have to divide each side by 1.01. So x would be equal to 165.3 centimeters. So if someone is 167 centimeters tall, they're going to have an arm span of about 65.3 centimeters. Now, if you want to try to figure out how tall 100 centimeters is in terms of feet, right? So it's 2.54 centimeters in a foot. So in an inch rather. So if I want to figure this out, I would do 167 divided by 2.54. So it's 65.7 inches. And so if I divide that by 12, that's about 5.47 feet. So it's about 5 feet and about half a foot. So it's about 5 feet and half a foot is 6 inches. So it's about 5 feet, 6 inches. So if someone's about 5 feet, 6 inches tall, they have an arm span of about, let's see, divide that by 12, about 5 feet and so it's about 5.4 feet. Okay, so their arm span roughly matches their height. Now, if you're trying to use the equation to predict someone who has an arm span of 196 centimeters, or predict the height of somebody with this arm span, then again, this is about 6.5 feet. Let's go back to what we were given. Okay, this was the data points we were originally given. Now, 196 is well outside of the data points that we have been given. Okay, so this is called extrapolation because it's extrapolation because it is outside the data points we've been given. So I'd put in, let's see, I've been given an arm span. So the arm span is my my x. Oh, actually, I'm going the other way around. I'm asking you to predict the height from the arm span. So if the arm span is my x, I've got to do this times 196, and that should be equal to my height. So if I do that, I would get my height would be about 197.96. Okay, so that's in centimeters, right? And that's how you use, that is the most important function of statistics, is using a scatter plot. So let's just go back what we did. We took some data points. This is very common to statistics. We took some data points from 6 people. Now, six people isn't a lot of people, okay? So we took some data points from 6 people. We made a scatter plot. From that scatter plot, we made a line of best fit. Okay, so we have this line of best fit right here. It happened to be a line of direct variation. Now, we used that line. We figured out what the slope and the Y-intercept was interpreted as according to the data that we have. And then we used it to predict, we used it to interpolate and extrapolate information, which is really what we want statistics to do anyways. If I'm trying to figure out, the average of, like time that people drive to work, or the average time that they take washing dishes or doing chores, I'm going to have to gather a bunch of data, use a scatter plot, try to figure out the line of best fit, which is sort of like averaging everything, and then use that to predict other things, right? Because prediction is a big part of statistics. Statistics is the collection, the organization, and and prediction using data. Okay, all right. So that ends our lesson for today. So our lesson was to find the line of best fit, the equation of the line of best fit, and using that to interpolate and extrapolate data.